Good evening, Aisha.
Good evening, ma'am.
Today I'm going to start real numbers exercise 1.1 solutions we will discuss here. Okay. So the first sum, write any three rational numbers. So we already know about the rational numbers. So rational numbers are in P by Q form. They are represented in P by Q form where P and Q should not be P and Q must be belongs to the integers, right? So P and Q must belongs to the integers family, and also Q should not be equal to the 0. So in denominator you should not have a 0. Like that we should write some examples for the P by Q form. Let's write 1 by 2, negative 1 by 5, all negative fractions also we can represent here, and 0 by 8. 8 by 0 I should not put, but 0 by 8 I can write. So 3 rational numbers. Hope this is sufficient. Okay. This is A bit. In this we also have a B question. Explain rational number in your own words. That means simply they are asking about the definition part. So what is the definition? Rational numbers are represented in P by Q form. Okay. Where P comma Q belongs to integers, or Z also you can write. Okay, integers we can represent I or Z. And Q should not be equal to the 0. In denominator we should not have a 0. This is the condition. So you can express this in your own words. Next question. Give one example each of the following statement. Let's see. A number which is rational but not an integer. So whatever the example we are giving, that should be a rational. Rational means it should be a P by Q form, but it should not be an integer. Integer, it should not be integer means, so what are integers? All negative numbers, zeros and positive numbers. Apart from that, we need to give one example for the P by Q form. So what do we can write here? Integers are, first I will mention, integers are negative 3, negative 2, negative 1, 0, 1, 2, 3, so on up to infinity, positive infinity. These are all integers, right?
Yes, ma'am.
So now you need to give an example, a number which is rational but not an integer. So I can give like this, negative 2 by 5 I will mention. Okay, see, integer means what? So these are all negative numbers, 0 and positive numbers. But there is no scope for the fractions in the integers, right? So here I have taken negative 2 by 5. Simply if I put negative 3 is an example. So then what it becomes, negative 3 by 1 is the P by Q form. But it will become again only integer. So don't give only integer. Okay. So it should not become integer, but it should be a rational number. So I have taken negative 2 by 5. Even you can give 1 by 3 also, right? 1 is the integer, but 1 by 3 if I mention, it's a rational number. Hope you understood. Yes?
Yes, ma'am.
Okay. Let's move to the second question. A whole number which is not a natural number. You need to write the whole number which is not a natural number. What are natural numbers? Natural number starts with 1, 2, 3, 4, 5, so on up to infinity. So a whole number which is not a natural number. What is the whole number? One and only whole number, and it is not a natural number?
0.
Yes, you are correct. So 0 is the one and only whole number, and it is not belongs to the set of natural number. So this becomes the answer for this question. Third question. An integer which is not a whole number. Already we mentioned here integers. So you need to give an integer, but it should not be a whole number. Whole number means what? 0, 1, 2, 3. So I can give the example of negative numbers, right? Because whole number starts with 0, 1, 2, 3, so on infinity. So here the question is an integer. Give an example for integer. It should not be a whole number. So remove the whole numbers from this. So what are the leftover things? Only negatives are leftover things. If you remove the whole numbers from the integer set, so what are the leftover? All negatives are leftover. So I can give any negative number as an example here. So -5 or -1 or -100, anything. Only negatives. So this will not become a whole number. A number which is natural number, whole number, integer and rational number. Yeah. See, you have to give an example here. It should be a natural number. It should be a whole number and also integer and a rational number. Rational number denoted with a Q. So one number only you need to select. It should have all such qualities. So what do we write here? So I will write an example of 6 by 1. See, is that 6 is a natural number?
Yes, ma'am.
Is that 6 is a whole number?
Yes.
Is a 6 is a in the set of integers?
Yeah, ma'am.
So I mentioned Q means Q is nothing but it is the integers. Sorry, Q is nothing but a rational number. Rational numbers we represent as a letter Q. Okay. So rational numbers we will write it in the form of P by Q. So 6 I can even write it as a 6 by 1, isn't it?
Yes, ma'am.
So you can take like that 5 by 1 or a 6 by 1 or 1. So 10 by 7 like sorry 10 by 1 like that. Okay. Again, don't take any other number in the denominator. What it becomes? It doesn't becomes a natural number or whole number or integer. It becomes only rational number. So better you choose one in the denominator. So it also satisfies these three conditions. Got it?
Yes, ma'am.
Yes. Next, fifth one. A number which is an integer but not a natural number. So you need to choose a number. It should be an integer only. It should not be a natural number. We know natural number contains 1, 2, 3, 4, so on. So you need to write integer. So what we can take? 0 we can take. It's not a natural number but it is an integer. Or minus numbers, any minus numbers you can take. So it is also integer but not a natural number. Right?
Yes, ma'am.
Yes, ma. So let's move to the question 3. Find 5 rational numbers between 1 and 2. So you need to write 5 rational numbers. Rational numbers between 1 and 2. Okay. So in between 1 and 2, first of all, if we have a seen a number line, 1 and 2. Is that many numbers lies in between this?
Yes.
No. Actually, if we have a mention like a 0, 1, 2, 3 like this, so no numbers can be written in between 1 and 2. But so how can we do this sum? See, so take 1 and 2 na, 1 and 2. So take these numbers and multiply with a rational number. What they asked, write 5 rational numbers. Rational numbers are in the form of P by Q. So you just take a P by Q form of one number. So I am taking this 1 into 10 by 10, 2 into 10 by 10. Listen carefully. We need to write 5 rational numbers in between 1 and 2. Okay. So rational numbers are in the form of P by Q. We all know that. P by Q form. So we need to get our answer. All those 5 numbers should be in the P by Q form. So how could we do that? So let's multiply. They asked 5 numbers now. 5 numbers means you choose a number which is more than 5. Okay. You can multiply 1 with 6 by 6 also, 7 by 7 also, 8 by 8 also. But always we feel very comfortable multiplying with the number of zeros. So I have chosen with the 10. Understood? You even can multiply with the 6, 7 or 8 or 9. Okay. But 10 is a easy multiplication for any number. Right? So more than 5 you take any number. So more than 5 means I choose 10. Okay. So the given number 1 multiply with 10 by 10. 10 by 10 is the P by Q form. And the other number also multiply with 10 by 10. What will happen if we multiply with 10 by 10? 10 by 10 get cancelled. Again you are getting 1 only. Na? And here also 10 by 10 you are cancels means 2 only. Na? So we are balancing here. Okay. Just. So these are the, so we are writing here equivalent fractions in the equivalent fractions you learnt in the previous classes. So now 1 into 10, numerator if we multiply 10 by 10 only. And here 2 into 10, 20 over 10. So now we can write many numbers. Many numbers means 9 numbers we can write in between 10 by 20. 10 by 10 to the 20 by 10 we can write 9 numbers at least, right? So let's write. So 11 by 10, the numbers are 12 by 10, 13 by 10, 14 by 10, 15 by 10. 5 enough, na? 5 numbers only they asked, so this much we can write. Okay. So in between 10 by 10 to the 20 by 10, we can write easily 5 rational numbers. Okay. Next. Fourth question. Insert 3 rational numbers between 3 rational numbers between 3 by 5 and 2 by 3. Okay, our question is insert 3 rational numbers between 3 by 5 and 2 by 3. Here this case is different. 3 by 5 and 2 by 3 are liked fractions or unliked fractions?
Unlike fractions.
What do you mean by unlike fractions?
The denominator will not be same.
Yes, you are right. So here the denominators are not equal. So hence we say them as a unlike fractions. See, we already know, we learnt already in the previous classes. So adding, subtracting two unlike fractions is not possible. Okay. So hence we make them, we convert them into a like fractions, and then we will do the addition or subtraction. Okay. So what we have to do, we need to convert them into a like fractions. How do we convert? By finding the LCM of the denominators. So LCM of denominators 5 and 3 is 5 and 3 are prime numbers. So what is the LCM? Product.
15.
Yes. So 5 and 3 are prime numbers. The product will become the LCM of those numbers. So 5 3 is a 15 is the LCM. So let's take this fraction 3 by 5. In the denominator we have a 5 here. So to make it as a 15, what we have to do? We need to multiply with the 3. So 5 3 is a 15, right? So multiply with the 3 by 3. Same way, take this another fraction. In the denominator we have a 3. Our LCM is 15. To make it 15, we need to multiply with 5. 3 5s are 15. So 3 3s are 9. 5 3s are 15. 2 5s are 10. 3 5s are 15. Okay. So now we made them as a like fractions. But the question is, insert 3 rational numbers between these two fractions. Is it possible in between 9 by 15 to 10 by 15?
No.
No. So now we will compare with the previous case. So in between 1 and 2 also we couldn't write sufficient numbers, rational numbers. So what did we do? We chose a number and multiplied with that. In this also same. So they asked insert 3 rational numbers. No. So more than 3 you need to choose. Tell me which number we will multiply. More than 3.
10.
Okay, it's easy. 10 means we can multiply easily, right? So even I will choose the group of zeros which is having, so 10. So multiply this fraction with a 10 by 10 and also this fraction also multiply with a 10 by 10. Okay, so 9 tens are 90, 15 tens are 150, right? 10 tens are 100, 15 tens are 150. Now we can write 9 numbers in between them, but we just need only 3 numbers. So we will answer to the question, that's it. So 91 by 150, comma 92 by 150, 93 by 150. Enough, 3 numbers are enough. Got it?
Yes, ma'am.
Okay. Fifth question. Represent 8 over 5 and negative 8 over 5 on number line. On number line. So, yes. First, whenever they asked you to mention these numbers on the number line, first you should check what is the whole number nearest, what is the nearest whole number for this number. Okay, we will take this fraction and divide and check. Okay, so let's divide. So 8 I am dividing with the denominator 5. 5 ones are 5. So 3 is the remainder. Put a so this can be written as mixed fraction. Quotient is a 1, remainder is a 3, and the denominator as it is 5. So 8 by 5 is nothing but 1 3 by 5. That means what? This 8 by 5 lies between 1 and 2. Understood? This 8 by 5 is lying in between 1 and 2 numbers. So the nearest whole number is 1 and 2 only. So now we got it. So easily now we can represent this. So let's mark the fixed distances first. What are the fixed distances? 0, 0. Oh, we have a negative number also. Now let's mark 0 in the middle. Okay. 0, 1, 2, 3. We just need 1 and 2 in between 1 and 2 numbers. And also here also negative 1, negative 2, negative 3. Now we got it. We need to mark 8 by 5 which is in between 1 and 2 and negative 8 by 5 which is in between negative 1 and negative 2. So now here one more thing. How to mark means what is there in the denominator? What
5.
is there in 5? So in between each number you should have a 5 divisions. Okay, in between each number you should have a 5 divisions. So let's do 1, 2, 3, 4. Fifth one is this number. So each fifth division should be your number. Okay. Next again 1, 2, 3, 4 and the fifth division is another number. 1, 2, 3, 4, fifth division. Here also in the same way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Why, ma'am, only fifth division? Why not a sixth or seventh division? Because, see, here if I have taken 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5 will become 1, right? So, when you are dividing in between each number, you need to rely on the denominator. So our denominator is having a 5, so make 5 divisions only. Every 5 digit you change. Okay, got it? So now our value is in between 1 and 2, right? So now this is 1. Next, 1 by 5, 1 2 by 5, 1 3 by 5. Is it ma? This is 1 by 5, 2 by 5, 3 by 5. So this is our required number 8 by 5. In the same way this also. So our number is in between negative 1 and negative 2. So here also. This is negative 1. This is negative 1 by 5, negative 2 by 5, negative 3 by 5. Okay. So this is negative 8 by 5. If you can count in this way also, negative 5 by 5, negative 6 by 5, negative 7 by 5, negative 8 by 5. From here you can start 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5, negative 5 by 5, negative 6 by 5, negative 7 by 5, negative 8 by 5. Hope you understood. Okay. So that's all 5 questions. So rest of the questions we will we can solve in next class. Okay.